Hello everyone, welcome to my YouTube channel. This is Debashri here. Last 1 year back, actually I uploaded one video in one topic like cell cycle and cell division I have discussed in my YouTube channel, and I got so many mails to upload spectroscopic techniques. So I am really inspired by this positive response. So today that's why I am here with you with spectroscopic techniques, right? Okay, I will be giving my mail ID in the description box. If you have any queries, you can drop mail to me in that mail ID. I will be coming to your queries and discuss those queries in the upcoming videos. And this spectroscopic techniques, if we before starting spectroscopic techniques, let me describe the word what is spectroscopic techniques, right? So spectroscopic techniques, spectroscopic comes from two words, spectro and then your scopic, right? Spectro means radiation. So spectro means whenever we talk about spectro, it deals or it means that radiation, and scopic means study. So it is basically when a radiation interact with matter, how it helps in determining the structure of that compound, or how the radiation helps in studying the studying concentration or structure of the sample. So with the help of radiation, when you study certain samples, certain biological samples, either their concentration or their structure, those techniques we call spectroscopic techniques. Fine. So let's move to next slide. So coming to electromagnetic spectrum. So electromagnetic spectrum is not a single range of wavelength or energy, right? So electromagnetic spectrum is basically the entire range of wavelength that exists between radio to gamma rays. So electromagnetic radiation is a, we can say, whenever we have got different waves of different energies and wavelength, the sum total of all the waves of different wavelength and energy, we call it electromagnetic spectrum, right? So for example, say we have cosmic, gamma, right, x-rays, uv, visible, infrared, microwave and radio waves. So this entire range of wavelength we call it electromagnetic spectrum, right? Now why are we studying about electromagnetic spectrum? This is because this electromagnetic spectrum has got different ranges of wavelength and different range of energy, which is described by microwave, infrared, ultraviolet, x-rays and gamma rays, right? Now when we need these electromagnetic radiations to study a sample, to study a biological sample, like for DNA, for proteins, these are used to find the structure and concentration. For example, say let me explain you. Suppose this is a sample here, right? This is a biological sample, say proteins. Now whenever a light is incident on this sample, say any light is incident on this sample, so what exactly happens? There are changes in the sample as well as also in the light. When you expose a sample with a light, there are after exposure, you will see that there are changes both in sample and light. So you can use any one of them to check, right? So generally we use light because it is easy for us to study. Now what are the changes it undergoes? Say when a sample is exposed to light, there are basically 4 changes which are going to take place. What are the 4 changes? It may shows absorption, emission, then scattering and ionization. So absorption means what? Some samples have a tendency to absorb the incident light, so that we call absorption, right? Emission means what? Some samples, what they do, after absorbing light, the electrons move to excited state, right? And after some time, when they return to their own orbitals, they release certain energy. Suppose this is an electron here, they have absorbed energy of incident light, gets excited and move to upper energy orbital, and after some time when they return to their own orbital, what they do is like they release certain energies, right? And this energy is having a longer wavelength and smaller energy than incident light, right? See, Yes, the incident light, when you expose a sample with light, this light will be having a higher energy and lesser wavelength. The sample, when they absorb this light, the electrons, because you know that sample is made up of atoms, of course, and atoms is having electron, proton and neutron, right? So this sample, now what they will do is the electrons in the samples absorb the light, move to higher energy state, right? After some time, when they return to their own orbital, they will release certain kind of radiations, and this radiation is different from incident radiation. How? Because this radiation will be having a lesser energy. Energy will be less compared to this radiation, right? And wavelength will be high. So this particular the light which is emitting after absorption of incident light, we call this changes as emission, right? Then next come your scattering. Scattering means what? Whenever, suppose this is a sample here, suppose this is a sample here, right? Now if we expose light, what it will do, it will scatter it in some different direction, right? So this is called scattering. So ultimately from this light, what we gain is that when you expose a biological sample or any other sample, what it do, when you expose this sample in the presence of a light, suppose this is a sample and this is a light, suppose. Now what it will do, when this sample is exposed to light, once the light interact with the sample, there are changes in both sample and both light, right? And these changes will calculate to study about the sample, right? So these are basically the changes which it going to show is absorptions, emission, scattering, ionization, right? On the basis of these changes, we will be dividing the spectroscopic techniques according to the changes shown by the sample, right? So let's move to the next slide. Yeah, just now we have seen the changes, right? So here in this slide, I tried to describe what does a spectrum measures, right? So this is a sample here and this is light here. So when sample is exposed to light, what it going to change is like it may show absorption, it may show emission, it may show scattering, and one more, that is ionization. Fine. So absorption means what? Whenever you expose a sample with the light, the sample will absorb certain amount of light, right? This we call absorption. And if we talk about emission, what exactly happens in emission? Suppose this is an electron here. What it will do, it will absorb radiation, goes to higher orbital, right? Then when it returns to its original orbital, it will release certain energy, and these energies will be having longer wavelength and lesser energy. Longer wavelength and lesser energy. Clear? So these things we call emission. Fine. Scattering also I have described. Scattering means what? Whenever this sample is exposed to light, this sample will scatter light in different direction, right? So this is called scattering. Fine. So I'm going to repeat this in Hindi also so that it will be easy for some students, right? Okay. जैसे ये एक सैंपल है, मान लो उस सैंपल को हमने लाइट से एक्सपोज किया. क्लियर? जैसे हमने उस सैंपल को लाइट से एक्सपोज किया, तो वो सैंपल क्या करेगा? 3 या 4 चेंजेस शो करता है. क्या क्या शो करता है? एब्जॉर्प्शन, एमिशन, स्कैटरिंग और आयनाइजेशन. अगर हम एब्जॉर्प्शन की बात करते हैं तो बेसिकली क्या होता है, जो सैंपल होता है वो क्या करते हैं, लाइट को कभी कभी एब्जॉर्ब कर लेते हैं. जब वो लाइट को एब्जॉर्ब करते हैं तो सैंपल में भी चेंजेस आते हैं, लाइट में भी चेंजेस आते हैं, राइट? तो उस हिसाब से हम उस पर्टिकुलर जो फेनोमेनन शो करते हैं उसको हम बोलते हैं एब्जॉर्प्शन स्पेक्ट्रोस्कोपी. और वहां पे अगर हम देखें जनरली एब्जॉर्प्शन स्पेक्ट्रोस्कोपी में अगर हम देखते हैं तो इसमें बेसिकली आता है विजिबल, राइट? देन यूवी विजिबल, यू कैन सी ESR, फिर इंफ्रारेड, फिर आता है NMR, राइट? सो बेसिकली ये आता है. एमिशन की अगर हम बात करते हैं तो इसमें शो करते हैं फ्लोरेसेंस. तो एमिशन क्या है? बेसिकली जब भी कोई इलेक्ट्रॉन, हमें पता है सैंपल हर चीज एटम से बनता है, वी नो दैट. सैंपल में भी एटम से ही बनेगा. कोई भी आप सैंपल ले लो, प्रोटीन्स ले लो, न्यूक्लिक एसिड्स ले लो, राइट? सैंपल से ही बनेगा. उसमें इलेक्ट्रॉन्स होगा, प्रोटॉन्स होगा, राइट? जैसे ही आप सैंपल को लाइट से एक्सपोज करोगे, जो इलेक्ट्रॉन्स होगा वो लाइट को एब्जॉर्ब करके हायर एनर्जी में मूव करेंगे, राइट। जब भी वो हायर एनर्जी में मूव करेंगे, थोड़ी देर में वो जब अपने ऑर्बिटल में वापस आएंगे तो वो कुछ रेडिएशंस एमिट करेंगे, कुछ रेडिएशंस वो छोड़ता है, राइट। अब वो जो रेडिएशन छोड़ेगा उसका और लाइट का क्या डिफरेंस है? लाइट का जो लाइट को हम इंसिडेंट रेडिएशन बोलते हैं, क्योंकि ये पहला है जिसको हम सैंपल को एक्सपोज करवाते हैं, राइट। तो जो इंसिडेंट लाइट है उसका एनर्जी क्या होता है, ज्यादा होता है और वेवलेंथ कम होता है। लेकिन जो आपका एमिशन होता है, मतलब जो ये वाला लाइट होता है, इसमें क्या होता है, आपका वेवलेंथ ज्यादा होता है। ज्यादा क्या होता है, वेवलेंथ। और जो एनर्जी होता है वो क्या होता है, एनर्जी कम होता है, राइट। सो एनर्जी कम होता है, राइट। सो ये कुछ एमिट कर रहे हैं, एब्जॉर्व करने के बाद उन्होंने कुछ एमिट किया उन सैंपल्स ने, राइट। तो उसको हम बोलते हैं एमिशन स्पेक्ट्रोस्कोपी। बेसिकली हम एमिशन में फ्लोरोसेंस स्पेक्ट्रोस्कोपी के बारे में पढ़ते हैं। अगर हम स्कैटरिंग की बात करते हैं, कुछ सैंपल्स क्या करते हैं, लाइट को अलग अलग डायरेक्शन में स्कैटर करते हैं। मान लो अगर से फॉर एग्जांपल ये आपका सैंपल है, राइट। और जब भी लाइट यहाँ पे आएगा, ये सैंपल क्या करेगा, लाइट को या तो इधर एक्सपोज करेंगे या इधर, अलग अलग जगह में वो लाइट को एक्सपोज करेंगे, राइट। उसको हम बोलते हैं स्कैटरिंग। और उसके हिसाब से, इस स्कैटरिंग के हिसाब से जो स्पेक्ट्रोस्कोपिक टेक्निक स्टडी करते हैं, उसमें बेसिकली दो स्पेक्ट्रोस्कोपिक टेक्निक हम स्टडी करते हैं, जिसको हम बोलते हैं क्या, रमन एंड एक्सरेज। रमन एंड एक्सरेज हम इसमें स्टडी करते हैं, राइट। और जो लास्ट वाला होता है उसको हम बोलते हैं आयनाइजेशन। आयनाइजेशन मतलब क्या, किसी भी सैंपल को आप फर्स्ट उसको गैसियस में कन्वर्ट करो, फिर उसको आप इलेक्ट्रिक फील्ड से सेपरेट करो। जो मॉलिक्यूल्स होते हैं वो अपने मास के अकॉर्डिंग सेपरेट हो जाते हैं, राइट। इफ यू आर हैविंग अ सैंपल एंड you have to convert the sample into the ionic phase, into gaseous phase, right. And when you expose it with electric field, the particles will separate according to their molecular weight or according to their masses, and this particular spectroscopy we call it mass spectroscopy. We call it mass spectroscopy. Clear? So this is all what I have discussed here, that how a spectrum measures. What does a spectrum measures, right? So I hope it's clear for you. If you have any queries, you can please drop it. If you have any doubt in any of the slides, you can drop mail to me, right? Let's move to the next slide. Hope you understand. Hope you understood. Okay. Here in this slide, I have kept to make you understand the energies and different wavelength of the light. See, for example, here, this cosmic and gamma rays. These cosmic and gamma rays, these are having highest energy. Energy of cosmic is greater than gamma, then ultraviolet, then infrared, then microwave, then TV. So if we simply say C, cosmic, gamma, X-rays, right? Ultraviolet, visible, clear, infrared, microwave, and radio wave. So this is a series of energy. This is arranged in the highest energy to lowest energy, right? Let me tell you one thing. We have studied this formula in class 12 also, right? E is equals to H nu, right? And if we replace, H is here Planck's constant and nu is here frequency, right? And if we replace frequency, it becomes C by lambda. Yes or no? C by lambda means what? Energy is inversely proportional to wavelength. That means what? If energy is increasing, the wavelength will be decreasing. Yes? Or if wavelength is increasing, the energy will be decreasing. So energy is inversely related to wavelength, right? And I told you that cosmic radiation is having the highest energy. That means the cosmic radiation will be having lowest wavelength. Why lowest wavelength? Because energy is inversely proportional to wavelength. Clear? So this is a series where the waves are arranged according to their highest energy. Cosmic, then gamma, X-rays, UV, visible, infrared, magnetic, microwave, and then radio waves. Clear? So this is all about the arrangement of waves according to their highest energy. Moving to next slide. So here I have kept a complete spectroscopic techniques in one chart. That means what are the changes, and according to the changes what we are going to name the spectroscopy, right? So for example, see here, if you see, if a spectrum, I told you that there are three changes basically takes place, right? तो वो changes हो सकते हैं absorption, emission, right? Absorption, emission and then scattering. Clear? If now अगर हम absorption की बात करते हैं तो वो light को absorb करते हैं. Clear? और उस बेसिस पे जो जो स्पेक्ट्रोस्कोपी आपका एब्जॉर्प्शन शो करता है वो है आपका यूवी विजिबल, एनएमआर, आईआर एंड ईएसआर. तो अगर हम if question comes in exam, what are the spectroscopy that is based on absorption, then it must be UV, visible, ESR, that is electron spin resonance, infrared spectroscopy and nuclear magnetic resonance. So this particular spectroscopy shows or depends or they undergo absorption, right? Fluorescent spectroscopy, if we talk about fluorescent spectroscopy, this means what? Whenever we expose a sample to the light, they absorb the wavelength, moves to higher energy state. Whenever they come back to their ground state, when they come back to their ground state, they emit radiations, right? And this radiation is having the lowest energy and longest wavelength, right? So this is we call fluorescent spectroscopy. So fluorescent spectroscopy, basically what it shows your emission, right? And if we talk about scattering, on the basis of scattering, there are two types of spectroscopy, Raman spectroscopy and X-rays. They scatter light in different direction, right? Another spectroscopy is there which we call ionization. Ionization means what? If you have sample, you have to change it in gaseous form, then you have to run it in the electric field, in the presence of electric field, right? And this basically this spectroscopy is used to determine the mass of a sample or mass of a molecule. Clear? So this is all about your spectroscopy, and these are the examples of spectroscopy based on absorption, emission, scattering and ionization. Fine? Okay, moving and here in this slide, whatever I have explained to you, that is I have written here so that if you go through the slides also, you can understand the concept very nicely. Clear? So this is today in this class I am covering bilkul basic part, right? In the upcoming session, we'll be discussing one by one about each spectroscopy. Next, this is a formula which is very simple. All of us have studied this formula in class 11, 12. In fact, in class 9th and 8th also we have studied, right? So this formula I have kept here to make you understand that energy is directly proportional to frequency, but it is what? It is inversely proportional to your wavelength. That means if frequency increases, energy will increase. But if wavelength decreases, energy will again increase, right? So frequency is directly proportional to energy and wavelength is inversely proportional, right? अगर frequency बढ़ती है, energy बढ़ेगी. अगर frequency कम होती है, energy कम होगा, right? अगर हम if we compare it with wavelength, अगर wavelength के साथ compare करते हैं तो क्या होगा? Wavelength बढ़ेगी तो energy will decrease, right? और अगर wavelength घटेगी तो energy बढ़ेगी. So this is a inversely you can say this is inverse relationship of energy with wavelength, right? Any doubt you have? If you have any doubt, you can please feel free to message me in my mail ID. You can drop a mail. So this is basic principle how this actually works. What are the principle of spectroscopy? So principle is that spectroscopy works on the basis of Beer-Lambert's law. Now what is Beer-Lambert's law? Yes, so in the Beer-Lambert's law, definition you will get in every book, right? So I'll not be going through definition, simply I'll make you understand the concept, right? So now if you have kept here a sample, say you have kept a sample, right? Now this sample will be having a particular concentration C, yes or no? This will be having a particular concentration, and L represents the path length of the sample, right? So if you expose the sample with radiation, then the amount of light absorbed by the sample is directly proportional to the concentration of the sample and path length of the sample. Clear? So absorbance is directly proportional to concentration and it is directly proportional to your path length, right? So if we write it in the formula, A is proportional to CL. To remove the proportionality, there comes a constant which we call molar extinction coefficient, Clear everyone? So this is Beer-Lambert's law. Fine. अगर आप कोई भी सैंपल को लाइट से एक्सपोज करोगे, देखो अगर आप कोई भी सैंपल लेते हो तो सैंपल का पर्टिकुलर कॉन्सेंट्रेशन और लेंथ होता है. कॉन्सेंट्रेशन होगा C और जो पाथ लेंथ होगा उसको हम रिप्रेजेंट करते हैं L से. जैसे ही आपने लाइट एक्सपोज किया उस सैंपल से, मॉलिक्यूल जितना एब्जॉर्प्शन शो करेंगे वो एब्जॉर्प्शन डिपेंड करता है कि कितना कॉन्सेंट्रेशन है और कितना पाथ लेंथ है सैंपल का, राइट? तो उसको बोलते हैं हम क्या? एब्जॉर्बेंस इज डायरेक्टली प्रोपोर्शनल टू कॉन्सेंट्रेशन एंड पाथ लेंथ. तो वो जो प्रोपोर्शनलिटी साइन है उसको हम रिमूव करते हैं विद द हेल्प ऑफ एक्सटिंक्शन कोएफिशिएंट, राइट? तो यही हो गया आपका बियर-लैम्बर्ट्स लॉ. बियर ने बोला था जो सैंपल है वो प्रोपोर्शनल टू कॉन्सेंट्रेशन बोला था, जितना कॉन्सेंट्रेशन होगा उतना सैंपल होगा, ये बोला था बियर ने. लैम्बर्ट्स ने बोला था जैसे ही आप जो भी आप सैंपल लोगे उसका जितना पाथ लेंथ होगा उसके हिसाब से एब्जॉर्बेंस होगा. तो दोनों लॉ को जब कंबाइन किया तो इट केम आउट एज अ बियर-लैम्बर्ट्स लॉ, right? And which describes that amount of light absorbed depends on the concentration of the sample and the path length of the sample, right? और इससे न्यूमेरिकल आता ही आता है. अब कोई भी कॉम्पिटिटिव एग्जाम्स, इफ यू अपियरिंग फॉर कॉम्पिटिटिव एग्जाम्स, डेफिनेटली विल बी गेटिंग क्वेश्चन फ्रॉम दिस पार्ट, राइट? Next, I kept here some properties of electromagnetic waves, which is very common and you have to know about it, right? So if we talk about this property, what are these properties? See, electromagnetic radiation has energy, but there is no mass. अगर आप electromagnetic radiation के बारे में बात करते हो तो उनके पास radiation होता है, but they don't have mass, right? Yes, they have energy, they don't have mass. Now if you travel it, if you expose the electromagnetic radiation in vacuum, they can travel. That means they do not need any medium for traveling. They can travel through a vacuum, right? और ये कैसे travels करते हैं? It appears in wave motion. Wave means crest trough like this, right? So it travels in wave motion. And it travels with the speed of the light. Speed of light is 3 into 10 to the power 8. Yes, so it also travels with the speed of light. Each wave has a frequency which is related to energy, and it is directly related to energy. That means the higher the frequency, the higher will be the energy. But this energy is related inversely to the wavelength. If energy high, wavelength decreases. If wavelength high, energy decreases. Right? So that's all for this class. If you like it, please hit the like button, and if you want more videos on spectroscopic, please let me know. I have shared my mail ID in the description box and you can drop your mail. If you have any queries, please feel free to contact. Thank you so much. See you soon with my next video.